So today's section is going to be covering 9.3, which we're going to be multiplying polynomials together. So again, remember as we're going through and we see some of this terminology that's showing up, reference back to our material from yesterday, 9.1 primarily, that has us working with and identifying our different terms that we have for, or different terminology, I should say, for how we classify polynomials. So monomials, binomials, trinomials was the big three that we primarily work with. It's all encompassed under these things being polynomials in general. But we're going to work today with multiplying those together. I want to emphasize the biggest thing that makes this particular section, I think everything else moving forward with polynomials very complicated, or very difficult, I should say, is if you are not using the distributive property correctly, all of this falls apart. That means when you're distributing a number through, you're distributing a variable through, you're distributing a sign through, you are doing all of that very, very carefully and very, very systematically. A lot of people will rush this step and subsequently not keep their work organized in that process. And we're going to see with a couple examples farther down here that these things can and will become a mess really, really fast if you do not do these two things. Primarily keeping your work organized. I think everyone has their own personal way of organizing the work, which I'm mostly okay with. As long as it keeps track of, you can keep track of what you're doing, what steps you're at, what you're doing next, what numbers are multiplying together. That's the important part. So first, we're basically breaking these things down into 3 different sections, even though not a whole lot is changing within them, but we'll work with our 3 different types here. So our first instance that we're going to work with of multiplying polynomials is if we are multiplying 2 monomials together. So remember, monomial is just a single term with everything multiplying together on it. It can have any number of variables in it, which we see with a couple of these examples here. But as long as everything is multiplying together, then we have 2 monomials. So how do we multiply these together? Well, it's the exact same process that we've been doing up until now. Basically, the problems that we were working on yesterday. We're just going to be applying those same ideas to these problems that we have here. So we'll jump over to our whiteboard and we'll go through these 2 examples really quick. Again, this should be a bit of a review from yesterday. But we'll go through them, just can't hurt to see more examples. Okay, so our first example with multiplying 2 monomials together, we've been given 2x, the quantity 2x, times the quantity 5x to the 7th. And just like we did yesterday, we're still going to be applying all of our exponent properties and rules to this thing. Those are not going away. Or no, it was yesterday. It was chapter 8 when we did those. All of our properties and rules with exponents, they are still going to apply here. There's no escaping that. And my recommendation as you're going through these, we have numbers and we have variables. Work these problems in parts. If you try and do everything at once, and you are able to, good for you. But if you can't do that, that's fine. Just work with the numbers, then the first variable, then the second variable. Just take it piece by piece. So we're going to work with 2 times 5. That's going to give me 10. And then I have x times x to the 7th. The bases are the same, and they are multiplying, which means the exponents are going to add together. I'm getting ahead of myself here. There we go. Which gives me x to the, or 10x to the 1 plus 7th power. We're going to write out that extra step. 1 plus 7 is going to give us 8. So my final answer to this first example is going to be 10x to the 8th. And in the second line of work, I wrote out the exponent being 1 plus 7 in there. You are not required to do so. I'm just showing that extra step with this problem as a bit of a refresher from what we did yesterday, and to see where we get that x to the 8th coming from. But again, you guys do not need to do that. If you can keep track of that stuff in your head or as you're going through it on your own, that's fine. So our second example, a monomial times a monomial. And again, remember with exponents, you want to correctly identify the base that is being raised to a power. If you don't do that correctly, then problems fall apart from there as well. So our second example has numbers, it has x's, and it has y's. And again, I highly recommend you guys, as you're going through this, work with those individually. Work with the numbers. I have 9 and I have -4. So 9 times -4, that's going to give me a -36. Positive times a negative is a negative. 9 times 4 gives us 36. Then we have x squared times x. Again, anytime we do not have anything explicitly written into the exponent spot, it is implied that the exponent is 1. It's implied, it's assumed, we're not going to deviate from that. So x squared times x to the first, add those exponents together because the bases are the same in multiplying, and we get x to the third. Then work with our y's. Y to the first times y to the 10th, combine those together, and we get y to the 11th. And we have our final answer. So these are our first two examples that we have with multiplying two monomials together. So very similar to what we went through yesterday. I'll jump us back over to our notes as we're going to go into our next section with this. So it was two monomials multiplying together. And now we're going to work with the instance where we have a monomial and a polynomial. So this polynomial over here, it could be a binomial, it could be trinomial, it could have 5 terms, 10 terms, whatever. Doesn't matter. We have a monomial times something over here. So our method to do that, we're going to distribute the monomial through to each term inside of the polynomial. And then we are going to multiply each term together and simplify. So we're going to go through these two examples. We kind of already have them written out here, just for you guys to reference later as necessary. But we'll go through these two examples on hopefully seeing how these things can start to become a mess if it's not apparent to you by looking at this right now. But we'll go see it for ourselves now. So again, we're told for these examples to simplify. So our first example that we have with monomials times polynomials, we have the quantity 2x times the quantity 3x plus 6. So here is where, as you're going through these processes, I'm going to show a few more gory details and steps on how we go through this, but there are some parts of these that, yes, you could go through and you could do a fair amount of this in your head, if you choose to. So our process we've been given tells us distribute the monomial through to each term inside the polynomial. I'm reading that verbatim from the notes, just on a different screen. So I'm distributing this 2x through to every term we have inside here. Now again, I'm going to show all of the details with this, at least in our first example. And you might be someone who's saying, well, I can see how these things distribute and what the result is going to be all in my head. And if you're in that boat, good for you. But I'm not requiring you guys to all be able to do that right now. So I've distributed the monomial through to each term inside of the polynomial. So I have 2x times 3x plus 2x times 6. And now I'm going to work with these things individually. So what is 2x times 3x? Well, 2 times 3 is going to give me 6. X times x is going to give me x squared. And I'm done with my first term. In my second term, I have 2x times 6. 2 times 6 is going to give me 12. There's no other x that is sitting over here at all. So the x that was originally there on the second term is just going to come down as it is. Nothing's changing about it. And that's actually a fairly common occurrence as we're going through and distributing these things. I look to see, do I have my answer in standard form, meaning in alphabetical order and by descending powers? Well, it's in alphabetical order, yes. And I have the highest power term listed first, so I'm good to go there, which means I am, oops, stay on the right page here, which means I am done with this problem. Now let's take a look at an instance where we have, let's get the preview of when these things start to get a little ugly. So our second example from that same example set, we have 4n times the quantity 3n squared plus n minus 2. There we go. So just like we did with our previous problem, the monomial out front, which is the 4n, is going to distribute through to every term we have inside here. And again, if you are able to go through and multiply each of these parts together in your head on your own, great, good for you. But I am not requiring that you guys do that. Now, I do want to draw your guys' attention, and maybe some of you have noticed this. In the first example that I did, I put this monomial out front in front of each of these terms as I multiplied them together. And in this example, I'm taking this and I'm putting it at the end of each of these terms as I distribute them through. There's no reason to do one over the other. Both work. There's nothing wrong with it. I'm just doing this so you guys are aware of the fact that we can write these things in kind of any order as long as they're all multiplying together. A lot of people get used to and stuck in the habit of it needs to be written this one specific way, otherwise it all falls apart. And it turns out that with this, we actually don't have to worry about that. It's one of the nice properties about multiplication. The order doesn't matter. Just make sure you have distributed everything through correctly as you're doing that. So looking at each of these terms individually, we have 3n squared times 4n. Work just with the numbers first. So 3 times 4 is going to give me 12. N squared times n is going to give me n to the third. And then I have n times 4n. Well, working with the numbers, there's only a 1 that's in front of the n. N times n is going to give me n squared. And then for the final term that we have minus 2 times 4n. So a negative 2 times a positive 4, it's going to give me a negative 8. There's no other n's in that term, so the n is just going to follow along as it was. So now I have multiplied everything together. I can't add or subtract anything, which is fine. And then we need to ask ourselves, is this thing in standard form? Meaning, is it going by alphabetical order and by descending powers? So the only variable that's showing up in here is n, so alphabetical order, check. And then by descending powers, the largest power out front, second largest, and then the third largest at the very end. So we're good to go there. Have this thing simplified and all written in standard form. And we'll jump back to our lecture notes here because we're going to go into the tougher ones, I think. By tougher, I mean there's just a lot more that goes on with them. So this is the more generalized one that we're going to have, which is going to show up as a polynomial and a polynomial multiplying together, where neither of them necessarily are monomials. So this process, again, I don't think the raw math behind it is necessarily the hardest thing to do. What makes these difficult is a lot of people rush their process. They just fly through it and want to get answers and write something down versus getting correct answers as we're going through and writing things down. So we have a polynomial multiplied by a polynomial. So our process for that. Distribute the first term from the first polynomial to each term in the next polynomial. So we're essentially going to have to do this in parts. So when we distribute that first term through, we're doing it the exact same way we just did this monomial times a polynomial. We'll be very systematically putting each of those parts through. Once we've done that, distribute the second term from the first polynomial to each term in the next polynomial. So you move on to the next one, distribute all of that through. Then you would move on to a third, maybe you have that shown up, and we do that as many times as necessary until all terms from the first polynomial have been distributed. Again, there is not a lot of raw math that is going into each of these. There's nothing really new that we are going to be covering. Actually, really isn't anything new in terms of doing this raw math here. Biggest part with this is keeping your work organized as you are going through it. A lot of people do not do that, and subsequently they lose points on this. And then once we have distributed everything through, we simplify by combining like terms, using PEMDAS, all of that, and then write the final answer in standard form. So we're going to go through 3 examples here, and if you're wondering, yes, it is a mess. But this is exactly why you want to be very organized as you're going through that. So let's take a look at these 3 examples over on the whiteboard that we have. I'm going to move us up. Let's do it up here. So our first example, where we had a polynomial times a polynomial, we have x plus 1 times 2x squared plus 3x plus 4. So in here, I have a binomial out front multiplied with a trinomial directly after it. Sorry about that. I had to cough. I didn't want you guys to hear that. So our process for this, again, a lot of this, the difficulty that comes into this section is people just rushing their work and trying to fly through this and just get an answer. We want the correct answer with it. So the first thing in our process, it tells us distribute the first term of the first polynomial to each term in the second polynomial. So our first one that we have out front here, we have x plus 1. I'm going to take the x and distribute that through to every term in this trinomial. So I have 2x squared times x plus 3x times x plus 4 times x. And I'm going to do this in 2 different colors here, just so we can see where everything is going through. So we have the x distributing through here, here, and here. And now we're going to take the plus 1 from the first polynomial that we have, and we're distributing that through to everything. And again, you might be looking at this saying, well, okay, well, it's just 1. I know what those numbers are going to be. I can do that mental math, and that's fine. I want to write this out because I think it's worth seeing how everything multiplies together here, or how everything distributes, I should say. So we have then the 1 distributing through. Okay. So the x distributed through first, so we have in blue. Then the 1 distributes through second, which we have in red. And now we can multiply everything together and simplify and combine like terms. So I have 2x squared times x. That's going to give me 2x cubed. Plus, I have 3x times x. That's going to give me 3x squared. Plus 4x. We're just going left to right from the line above. I then have 2x squared times 1. That's just going to be 2x squared. 3x squared times 1, or not 3x squared, it's going to be 3x times 1, which is 3x. And I have 4 times 1, which is just going to be 4. And now we're looking to see, can I combine any like terms in here? And yes, we can. I'm going to use green here for this. I'm seeing I have x squared and x squared showing up. So when I combine those together, I'm going to get 5x squared. Remember to combine like terms with variables. The variable and all of the exponents must be the exact same. And if they are, then I can add or subtract the coefficients together, the numbers up front. So I have the x squared terms we brought together. I have x terms, which we can also bring together. So 4x plus 3x, that's going to give me 7x. I can't add anything to the 4 because it's just a constant. I can't add anything to the 2x cubed. That's a cubed term. I don't have any other terms like that. So I've combined together everything that I can in this problem. It's fully simplified. And our last step, we need to rewrite this thing in standard form if it isn't already like that. So is it in alphabetical order? Yes, the x is listed first. Is it by descending powers? Yes, it is. Got the 3, then the 2, then the 1, then technically a nothing there. So this thing is written into standard form. We are good to go. So we're going to move on to our next example that we have. So our next example, number 2 from this set, we were given x squared minus 3x, 3 plus 1 equals x squared plus 4x minus 2. And if it wasn't abundantly clear from the last example, we are going to have a lot of things written out here. A lot of things are distributing, a lot of things are going to be multiplying, a lot of things are going to be adding or subtracting together. So I'm hoping before I go through this, the point has been hit home that you absolutely want to keep your work organized as you are going through these. If it didn't hit home last time, I'm really hoping it will with this one, because yeah, this is going to get gross. But again, we have a process that we're just going to follow it. So distribute the first term from the first polynomial to each term in the second polynomial. So I'm going to work with this x squared first, and that's going through to everything in the second polynomial. So I have x squared times x squared plus 4x times x squared minus 2. Come on, pen, don't do this to me. Times x squared. So I just distributed that first x squared from the first polynomial through to everything in the second polynomial. Now I'm going to be doing the same thing, but with this minus 3x. So I have x squared times minus 3x plus 4 times minus 3x. I'm going to jump us down, or bring this part down here, but we're continuing. Minus 2 times negative 3x. So I've just distributed the second term from the first polynomial through to the second polynomial. And now, last but not least, I'm distributing the third term from the first polynomial through to everything in the second polynomial. And again, I'm showing this in gory detail with everything written out because it is worth seeing it written this way, at least once. So we had the x squared distributing through, we have here. We have the minus 3x distributing like we have here. And then we have plus 1 distributing through like we have at the very end over here. And again, as you are going through this process, and if you on a case-by-case basis want to be multiplying some of these things together and simplifying along the way, you're welcome to do so. I would just be very, very cautious and make sure you are keeping all of your work in line. You are not skipping anything or forgetting to do anything, multiplying together there. But it is an option for you. I just find that people that rush themselves on these problems, especially when they show up on the test, they end up missing a lot of answers because they just speed through it to try and just get done, not to get the right correct answer on these. So now we're multiplying each of these terms together. I have x squared times x squared. We're just going to go left to right, top to bottom. X squared times x squared is x to the fourth. I have 4x times x squared. I'm just doing these in parts. And then minus 2 times x squared minus 2x squared. Next, we're working with x squared minus 3x. It's going to give me a negative 3x to the third. We have 4 times negative 3x, which is going to be minus 12x. And then we have a negative 2 times negative 3x. Negative times a negative is a positive. That's going to give us 6x. And then last but not least, we have x squared times 1, which is going to give us x squared. 4x times 1, which is going to give us 4x. And then minus 2 times 1, which is going to give us negative 2. And now I'm combining like terms together where I can. I'm going to be getting, oops, there's an error showing up. I did not put an x in there. So that one is on me. There we go. Let me rewrite this to be a little bit neater. 4x. So now I am combining like terms where necessary. X to the fourth, I don't have any more x to the fourths in there, so that's fine. I'm just going to leave that as it is. I have 4x to the third. I have 2 of those, 4x to the third here, and minus 3x to the third there. So the variables are the same, the exponents are the same. I can add the coefficients together. 4 minus 3 is going to give me negative 1. So I'm going to have minus x cubed, or minus 1x cubed. Working with the squareds. I have a squared term here, squared term here, squared term here. So I have negative 2 minus 12. That's going to give me negative 14. Plus 1, which is going to give me a negative 13. And then I'm looking at my x's. I've got a 6x and I have a 4x showing up. So combining those together, that's going to give me a 10x. Again, the variable stays the same. It's only the coefficient that changes. And then that minus 2 on the very end, well, I can't combine that with anything else. I can't change it at all. So it's just going to come down as it is. I can't combine anything else, so I have fully simplified this problem. And then we ask ourselves, is this written in standard form? Alphabetical order? Yes. By descending powers? Yes. So we are done. Okay. So again, I'm hoping it is becoming abundantly clear that you want to keep your work organized as you are going through this. These are not very easy problems if you are just throwing numbers around and throwing terms here and there just because. If you're doing that, you're probably going to be getting wrong answers. And again, taking these things in parts, just do this at a time, just do that, just do that, just do that. As soon as you break these things down, the individual operations and calculations that we're doing I don't think they're particularly difficult. It's very similar to what we were just doing earlier. So don't be afraid to write out some extra lines of work for yourself. Don't be afraid to take a little bit of extra time to make sure it's organized. It goes a long way. Now move over here and we'll go through our third example that shows up with these. So our third example, we're starting with x squared times x minus 1 times 2x plus 3. So we're doing things a little bit differently with this one. Up until now, we have only been working with one polynomial times another polynomial. So just two things multiplying together. Now we have three things that are multiplying together. And this is an instance where a lot of people, again, will just gut reaction says this, that does something, and I'm just going to go and do that because I don't know why. When you have a scenario like this, where we have 3 or 4 or 5 polynomials multiplying together, only do 2 at a time. It does not matter which 2 you choose, but only work with 2. Simplify those down. Then work with the next 2 that you choose. Simplify that down and repeat that process as necessary. So for this example, we have 3 polynomials here. We have x squared, we have x minus 1, and we have 2x plus 3. Now, again, choose 2 of these polynomials and only work with those 2 at a time. So I am arbitrarily choosing to work with x squared and x minus 1. You could choose instead to work with x squared and 2x plus 3. That works. Or you could say I want to work with x minus 1 times 2x plus 3. You could do that also. It's your choice on which 2 you want to work with first. You just have to pick 2 and then move forward with it. There's no right or wrong on which one is better, worse, right, wrong, any of that. So I'm only going to work with x squared times x minus 1. So looking just at those, I'm doing the exact same thing as I did previously. This x squared is going to distribute through to every term inside that polynomial. So I'm going to get that showing up for my first set of multiplication. Nothing is happening to the 2x plus 3 for right now, so that means it's just going to come down as it is. We're going to work with it later, but for right now, we're not affecting that at all. Looking at that first set of parentheses, I have x times x squared. That's going to give me x cubed. And 1 times x squared is just going to give me x squared. Nothing is happening to the 2x plus 3 for now, so that's fine. We can leave it as it is. But I've just worked with multiplying the first 2 polynomials together, and now I have that answer. Great. Now I need to multiply these 2 polynomials together. So the x cubed in the first is going to multiply through. Again, we're just using the distributive property here. So we have 2x times x cubed plus 3 times x cubed. And then we're taking this negative x squared, and that's going to distribute through. So again, the actual raw distribution process, nothing is changing from what we did previously. So we have the x cubed distributing there. We have the negative x squared distributing through there. And now we just multiply and simplify all these things together, just like we did previously. So I have 2x times x cubed. That's going to give me 2x to the 4th. Plus 3 times x cubed. It's going to give me 3x cubed. Then I have 2x times negative x squared. A positive times a negative is a negative. 2 times 1 is going to be 2. X times x squared is going to give me x to the third. Divided by 3. And then lastly, I have 3 times negative x squared. Positive times a negative is a negative. 3x squared. And now from here, combine like terms where we can. I don't have any x to the fourths, so that's fine. The term is going to stay as it is. We then have 3x cubed minus 2x cubed. So 3 minus 2 is going to give me 1 x cubed. And then this minus 3x squared at the very end, I can't combine that with anything else. So we get to that there. We have fully simplified this thing, and now we ask ourselves again, final step, is this thing in standard form? Is it written in alphabetical order? Yes. Is it written by descending powers? Yes. So nothing else I can do with this problem. Done. So again, the big takeaway I want to emphasize with these, up until now, we only had 2 things multiplying together like we did here. I'll zoom this out here a little bit, that might make it a bit easier to see. We only had 2 things multiplying together here. Only had 2 things here. Only had 2 things with all of these other ones. So again, as soon as we introduce more things being multiplied together, like we have with our example here, do not multiply everything together at once. Do not choose, I want this monomial multiplying to every single polynomial that comes after it. Only work with 2 at a time. If you do anything other than that, you're going to get the wrong answer. I guarantee you, because the math is wrong if you do it that other way. So when you have multiple polynomials, like we have here, it is your call, but choose 2 of them and multiply them together. Then choose the next 2 that you want to multiply together, and then choose the next 2 that you want to multiply together. It is piece by piece bringing this all out in the open, distributing everything, and then simplifying it down. Again, I cannot emphasize that part enough. Taking that extra time to organize and make sure you are very systematic with what you're going through and how you're going through these. I'm again going to go out on the limb of, I don't think this is some of the toughest math that we have done this quarter. I think we've done things significantly harder than just multiplying each of these things together. Which means if you keep doing these very, very methodical steps and processes that we have, you keep life a bit easier for yourself as you're going through and solving them. So that's my recommendation. That's my advice with these. It's your call and if you would like to use that or not, but be very, very, very careful if you don't. So that is everything for the 9.3 material. I'll end the recording there, and I might be able to take 1 or 2 really quick questions here.